Okay, so this is 2.8. This is the last chapter, the last part of chapter 2. We're going to talk about functions and just adding and subtracting them and then doing compositions. So here are your rules. So you can, if they tell you to add two functions, you're just going to add the two pieces together, add your like terms. Same thing with subtraction. Just make sure that when you do subtract, that there's actually parentheses around the second one so that if it's more than one part, you're distributing that negative sign to all the parts. X times g of x, multiply the two, and then f divided by g of x, one function divided by the other. The domains of f plus g, f minus g, and f times g are going to be all real numbers, and the domain of f divided by g is going to be all real numbers except for any number that would make your denominator 0. So let's dive in here. So it says to add. So f plus g of 1. So all you're going to do is you're going to take f of 1 plus g of 1. So that's going to be 1 squared plus 1 plus 3 times 1 plus 5. So 1 squared is 1, 1 plus 1 is 2, 2 plus 3 is 5, and 5 plus 5 is 10. And that's all you have to do is just plug that 1 in for all of your x values and add them together. So now we're going to do f of negative 3 minus g of negative 3. So this is negative 3 squared plus 1, which is 9 plus 1, which is 10, minus, so now we've got 3 times negative 3 plus 5. So here we've got 3 times negative 3 is negative 9, and negative 9 plus 5 is negative 4, so this is minus a negative 4, and two negatives make a positive, so the answer is just 14. Multiply them, so now we've got 5 squared plus 1 times 3 times 5 plus 5. So this is 25 plus 1, which is 26. And this is 15 plus 5, which is 20. 26 times 20 is 520. And here we have 0 squared plus 1 divided by 3 times 0 plus 5. 0 squared cancels out, 3 times 0 cancels out, and you are left with 1/5. So when they're asking you to add, subtract, multiply, it's pretty straightforward. All right. Now let's look at using operations on functions to determine the domains. So here it says f plus g. So you're just going to add these two together. So you have 8x minus 9 plus the square root of 2x minus 1. And that's all underneath the square root. Now, what's the domain? Well, the domain, remember, for this part is all real numbers. But this part is under the square root, so it cannot be you can't have a negative number under that square root. So we need to check and see what's going to make it 0, because it can be 0, it just can't be anything less than that. So 2x minus 1 equals 0. 2x equals 1, x equals 1/2. So that means that if I plug in a 1/2 right here, that gives me 0. So I can't use any x value less than 0. So my domain is 0 to infinity. So I can use any positive number. All right, the next one here we've got to subtract them. So now we have 8x minus 9, because that's the f part, minus the square root of 2x minus 1. And your domain's going to be the same because 2x minus 1, you still, well, this is not 0. This is 1/2 because I can't use 0 because 0 would make it negative. So it has to be equal to 1/2 or anything greater than. So same thing over here, 1/2 to infinity. Now when you multiply them, so let's see here. I'm doing part E with this as we're doing the domains. So you'll see that the domains are the same. When you multiply them, you have 8x minus 9 times the square root of 2x minus 1. Again, the square root can't be anything negative, so the domain is 1/2 to infinity. And then to divide, so now we're going to divide them. So now I have 8x minus 9 divided by the square root of 2x minus 1. Now, the 2x minus 1, if it's equal to 0, we find out that x is 1/2. That's why we're using these brackets on the 1/2s on all of these, because when I'm adding, subtracting, or multiplying, you can have a square root of 0 and get 0, but if I were to plug in that 1/2 now, that would give me a 0 in the denominator, and you cannot have a denominator that's 0. So now it's still 1/2 to infinity, but this time you use just plain parentheses for your domain because you can't use the 1/2. If you use the 1/2, then that makes your problem undefined. So this time it's everything up to 1/2, but not 1/2. All right, so that was all of those in a nutshell. All right, now what happens whenever they give you different scenarios? So what we're going to do is we're going to find f of 4 plus f of g in each one of these scenarios. So they're saying that f of 4 plus g of 4. So when x is 4, what is y on the f of x? So that's 9. And when f of 4, what is it on the g of x? That is 2. And 9 plus 2 is 11. So if I go over here to my table, if x is 4, that's 9 and 2. So again, f of 4 plus g of 4 is 9 plus 2, so that's 11. Okay, so now we have done f of 4 on A and on B, and notice it's the same information for both. It's just different ways of looking at it. So whether you're given a graph or a table or even an equation. So we're going to go down here. We're going to go down here and we're going to do f of 4 is 2 times 4 plus 1. 8 plus 1 is 9. And g of 4 is the square root of 4, which is 2. All right, so now, and again, if we add 9 plus 2, we get 11. So you get the same answer on all three. It's just different methods of looking at it. All right, so now let's look at f minus g of 2. So now we're going to find negative 2 on the x-axis. So if I go to negative 2 on the x-axis, I look down and I see that f of negative 2 equals negative 3. Now, if I do g of negative 2, there is no g of negative 2. It's undefined. So therefore, there's nothing to do here. So the answer would just be undefined. F of negative 2 is negative 3. G of negative 2 is undefined. So f minus g of negative 2 is undefined. And then down here, if we plug in a negative 2, f of negative 2 is 2 times negative 2 plus 1. So negative 4 plus 1 is negative 3. G of negative 2 is the square root of -2, which is undefined because you cannot take the square root of a negative number. All right, and let's look at f times g. So let me change my ink here. So f of 1, so go to 1, go up to f and look over, and that's 5, 4, 3. So f of 1 is 3. G of 1 is also 1. So 3 times 1 is 3. All right. Here, f of 1 is 3. G of 1 is 1. So 3 times 1 is 3. Same thing down here. Plug it in. F of 1 is 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 is 3. G of 1. So the square root of 1 is 1. 3 times 1 is 3. So you get the same answer no matter what. 3 different methods. And last we have f of 0 and g of 0. So f of 0, so 0, 1. So f of 0 is 1. G of 0 is 0. 1 divided by 0 is undefined. Now looking at your table, f of 0 is 1. G of 0 is 0. 1 divided by 0 is still undefined. And last, we'll do it down here. F of 0. 2 times 0 plus 1 is 1. G of 0, the square root of 0 is 0. 1 divided by 0 is still undefined. So, whether you have a table, a graph, or actual equations, just find your x, and then match it up with your y, and then do the actual function. All right, now this is called the difference quotient. This one can get a little long. I hope these notes aren't as long as the last set. I do apologize for the length of those, but sometimes it just can't be helped. So one thing I want to point out is, notice whatever we replace this x with, we replace this x with. Well, we're going to replace that x with x plus h. It looks really weird. But before we start, I want to go over a rule that if you've just come out of Algebra 2, you may be a little more familiar. If you have not just come out of Algebra 2 and it's been a minute, then let this be a reminder. So let me do this. You're going to have to do that here, okay? So what we're going to do is we are going to replace this x with x plus h. So we've got 2 times x plus h squared minus 3 times x plus h. That takes care of this. Minus, now we're just going to subtract the function. So now you're just going to subtract that. 2x squared minus 3x. All divided by h. So now we're going to go through and do each step. So I've got 2 times, notice this x plus h squared. So this is going to be x squared plus 2xh plus h squared minus, now distribute the 3, and then distribute the negative sign. All divided by h. All right, now distribute this 2 to everything here. So we've got 2x squared plus 4xh plus 2h squared, and then everything else just drops. 3x minus 3h minus 2x squared plus 3x all over h. Now here's the fun part. Take inventory of what you have. If you have the same thing with a plus and a minus, cancel it out. So I've got a 2x squared, and I go through and I see I have a negative 2x squared. So those are going to cancel each other out, so they're gone. Now I have a 4xh. There's no more xh's, so I'm going to come over here and write 4xh. I have a 2h squared. There's no more h squared, so plus 2h squared. So I've used that. Now I've got negative 3x plus 3x. Those are gone. They cancel each other out. And then I have negative 3h. And all over h. So now what I have here is I have an h in everything. So I'm going to factor out an h. So that's 4x plus 2h minus 3 all over h. Now these h's cancel. My final answer is 4x plus 2h minus 3. So as long as that seems, that is how it works. And it will follow the same pattern over and over. Anytime you have an x squared and you have to plug something like this in, it's going to follow this rule right here. So make sure that you have that written down. So it says find and simplify the expression for the difference quotient. So we used this function, we used the difference quotient, and this is the answer when you're done. Now, the next thing we're going to do is talk about the composition of functions and the domain. Now, we were adding and subtracting and multiplying and dividing. Now we're doing what's called a composite. This doesn't mean times. It means f of g of x. So you kind of work from the inside and you work your way out. So what you're going to do is the x value of f of x is whatever g of x is equal to. So you find g of x first, then that answer is your new x value for x in the f of x. So let me show you how it works. So we're going to do f of g of 2. So what I'm going to do is f, and I'm going to plug this in. 4 minus x minus 1. Actually, let me write it down like this. So the first thing I'm going to do is I'm going to find g of 2, okay? So I'm going to come down here and I'm going to go, okay, g of 2 is 4 over 2 minus 1. 4 over 1 is 4. So since g of 2 is 4, this is f of 4. So now I can plug the f function in to find f of 4. So that's 2 times 4 minus 1, which is 7. So f of g of 2 is 7. So you work from the inside out. So this one over here, we have g of f of negative 3. So we're going to find f of negative 3 first. So f of negative 3. So you're going to use f. So that's 2 times negative 3 minus 1. So that's negative 6 minus 1, which is negative 7. And now you're going to do g of negative 7. And g is this function here. So you got 4 over negative 7 minus 1. So 4 over negative 8 is negative 1/2. So g of f of negative 3 is equal to negative 1/2. So work from the inside out. Okay, if you have, let's say we have x plus 2, and we're going to square it. So what that means is x plus 2 times x plus 2. Now, to solve this, you distribute. X times x is x squared. X times 2 is 2x. And now you do 2 times x, so that's 2x. And 2 times 2 is 4. And now you combine your like terms. So this is x squared plus 4x plus 4. Now, what I want you to notice is there's a pattern. So basically what happens is you take the first, and this only works when this is x plus 2 or x plus 4, x plus something, or minus, okay? Now, you take the first term and you square it. You take the last term and you square it. So 2 squared would be 4. Notice I left a space. Now you multiply these two things together. 2 times x is 2x. Now double it. 2x times 2 is 4x. Notice that we got the same thing. So it's a pattern. Basically, the rule says a plus b squared is equal to a squared plus 2ab plus b squared. This is the rule. You square this, you multiply these, and double. And I tell you that because it follows this. All right. So now, what if they just give you two functions and they want you to determine the domain of these functions? So we're going to do f of g of x. So that means I'm going to replace the x in my f of x with the function of g, because you're replacing this with this. So that means f of 4x plus 2. Now, what is the function? So this is g of x here. So you've got the square root of 4x plus 2. Now, this is f of g of x is equal to the square root of 4x plus 2. Now, what is the domain? So I know that my domain, first of all, for this function, for f of x, the domain is all real numbers, because I can plug anything in. Actually, I cannot plug a negative in because it is a square root. So it is not all real numbers. It is 0 to positive infinity, because I have to have positive numbers there. For my g of x, it's all real numbers. So g of x domain is all real numbers. Now, does that mean that you can only go to 0 for the domain of this function, or can you use everything? Well, take your what's underneath, so your 4x plus 2, set it equal to 0, because this can be equal to 0. It actually has to be greater than or equal to 0. So 4x is greater than or equal to negative 2. X is greater than or equal to negative 2 over 4, which is negative 1/2. So that means the domain of this function is negative 1/2 to infinity. It can actually be negative 1/2 because I can have it 0, but I can't have it be less than 0. So we can use the negative 1/2. Now on this side over here, we're going to do g of f of x. So that means you're going to take your 4x plus 2, and you're going to replace your x's with f of x. So f of x is the square root of x plus 2. So now, in this particular function, it can be 0 or less. It can't be less than 0. So 0 to infinity is your domain. Because if x is 0, then the square root of 0 is 0. 4 times 0, 0. 0 plus 2 is 2. So it works. You just can't use anything less. All right, so here we have another one. This one is a little bit more detailed. So f of g, so f of g of x. So that's going to be, since g of x is 1 over x, so f of 1 over x is going to be 6 over 1 over x minus 3. So that's our function that we're working with. So I want to clean this up a little bit. I'm going to pull back some elementary division because I know if you're not doing math all the time and you didn't come straight out of high school, some of these rules may or may not have slipped your mind. But I just want to go through them and make sure that everybody's good. So what we have is, this is going to be a little side piece here. So I have 6 divided by 1 over x minus 3 over 1. I want to make my denominator be one term and not two terms. So I need to multiply the top and the bottom by x so that my denominator is the same. So now I have 6 divided by 1 minus 3x over x. Now this says 6 over 1 divided by 1 minus 3x over x. And if you remember your rules when you did division, when you were learning it, you keep the first fraction, you change your division to multiplication, and you flip the second fraction. So now we've got multiply straight across 6x, and then 1 times anything is unchanged. So what we have is f of 1x equals 6x over 1 minus 3x. So that is the composition of f of g of x. Now, what is the domain? Well, first off, in the f of x part, x cannot be 3. So from negative infinity to 3 and 3 to infinity, because it can be all real numbers except 3. And then this one here, it can't be 0. That's the only thing it can't be. So negative infinity to 0 and 0 to infinity. Other than that, everything works. Now, what we want to know, let me find my little side notes here, because I wanted to make sure that I don't forget to tell y'all any part. Okay, so what we want to know is if this piece right here, okay, if it can't be 3, because remember we just said here that when we're looking at, scroll down here, when we're looking at the f function, x cannot be 3. So what is going to make this piece be 3? So I'm going to come over here. So 1 over x equals 3 over 1. So I've got 3x equals 1, divide by 3, x equals 1/3. So now what we're seeing is that the way that this piece, if this piece is 3, this is not going to work because f of x, okay? So that means that x can't be 1/3 either. So then we go through here and we're like, okay, then I know that x cannot be 0, x cannot be 3, x cannot be 1/3. So as a whole, the domain is negative infinity to 0, 0 to 1/3, and 1/3 to infinity. So that is the domain of the f of g of x. Now, I'm going to do this piece on a second slide so that it's not scrunched up together. All right, so this next one says g of x, g of f of x. So g of f of x. So we've got, so we're going to replace g with f of x, and f of x is 6 over x minus 3. So now you take your g function, which is 1 over x, and replace that with 6 over x plus 3. not plus, that's a minus, sorry. So now I've got 1 divided by 6 over x minus 3. The rule is keep, change, flip. So it just becomes x minus 3 over 6 equals x minus 3 over 6. Well, I don't have to worry about anything in the denominator because the 6 will never be 0. So we just need to look at, well, then what can, we know that this number right here can never be 0. This is never going to be 0. So then our domain for this piece is negative infinity to 3 and 3 to infinity. So it can be all numbers because this piece right here can never be 3. And we don't have to worry about the whole thing being 0 because 6 will never be 0. All right, so that takes care of that. And then now we have the last part. So this one says, show that g of f of x is not equivalent to f of g of x. So you're just going to replace one with the other. So I'm going to do g of f of x. So g of, and we're going to replace x with what f is. So 4x plus 1. And now I'm going to take this, oops. So I've got 2 times 4x plus 1 squared plus 5 times 4x plus 1. All right, so now remember the 4x plus 1 follows that a plus b squared. So this is 2 times 4x squared is 16x squared. 1 squared is 1. 4x times 1 is 4x times 2 is 8x. And then distribute. Now distribute the 2 across. And then go ahead and bring down your 20x plus 5. Now go ahead and take inventory of what you have. You got 32x squared, 16x and a 20x, that's 36x. 2 plus 5 is 7. So g of f of x equals 32x plus 32x squared plus 36x plus 7. Now, they want to know, is it equal to f of g of x? So again, I'm going to do it on a separate sheet where it's not scrunched. All that g of f is 32x squared. G of f of x is not equal to f of g of x. And then our last part. So they've given me a composite and they want us to figure out, well, which part is the f of x and which part is the g of x. So this is how you do it. So we know f of g of x. So we want to know which part is g of x. So I see that this piece right here is repeated. So I'm going to say, well, g of x is x squared minus 5. And if that's the case, then this was replaced and this piece right here was replaced. So that means f of x is x cubed minus 4x plus 3. So you take the piece that's repeating, that's probably filling in for the original x. So you replace the original x with all of that. Take the original x and replace it with that. So this is your g of x, and this is your f of x. And that wraps up 2.8 and chapter 2. So f of g of x is f of, now what is g of x? G of x is 2x squared plus 5x. So now I'm going to take the function f, which is 4x plus 1, and I'm going to replace all the x's with all of that. So this is 4 times 2x squared plus 5x. And then, so I replaced this with this, because remember, f of x was replaced with that, so let's replace x with that, and then we got the plus 1 at the end because that's the rest of the function of f. So 8x squared plus 20x, because you got to distribute the 4, and then plus 1. And that is f of g. So f of g is 8x squared. So therefore,